Alright, here we are in transformers. This is a very basic symbol for a transformer. And we're going to look at that first before we look at any connections or any other parts of the circuitry. Alright, so the transformer symbol itself is going to tell you a lot about it. For instance, this is a step-up transformer because we see it has a 3 to 5 ratio. That is what that 3:5 is. It's a number that's based on either the actual number of turns or the ratio of the number of turns. In other words, if the number of turns in the primary was 60 and the number of turns in the secondary was 100, then you could simplify that down to 3 to 5. Now, it tells us other things. We're going to talk about what those dots mean on the transformer. We're also going to talk about those straight lines down the middle. So we're going to ask a few practice questions to kind of bring out this information. Alright, so what type of transformer is it? We already know it's a step-up transformer, but what else do we know about it? Well, these lines down the middle right here, these two solid lines straight down the middle, that tells us that this is an iron core transformer. And iron core transformers are typically used in power applications. So we know that. Alright, now what is the output voltage? Well, that we're going to use our ratio formula for. So what we have is, and I'm going to throw it up there, what we have is a formula here. It's based off ratios, and it uses cross multiplication to determine the answer. And let's talk first about what everything stands for. The NP stands for the number of turns in the primary, and the NS, number of turns in the secondary. EP, voltage in the primary. ES, voltage in the secondary. IS is current in the secondary, and IP is current in the primary. So we have some of those pieces. We have the number of turns in the primary, number of turns in the secondary, and we also have voltage in the primary. So we're going to fill those in. We put our 3/5 for our ratio, and we put our voltage of 72 for our primary in. Well, if we use our cross multiplication, we're going to take 72 multiplied by 5 to get 360. And then we're going to take 360 divided by 3 to get 120. And 120 is the voltage in the secondary, which makes sense. This is a step-up transformer. If we have 72 volts in the primary, we would have more in the secondary, and we do. We have 120 volts. Alright, let's try another one. What is the output signal in phase or out of phase with the input signal? Well, now we get back to those dots that are on the transformer. You'll see there's a dot on the top and one at the bottom. That indicates that the signal is out of phase. And I'm going to throw up a little waveform there. So you'll see on the primary, the negative part of the signal is first, and the positive part of the signal is second. But on the secondary, the positive part is first, and the negative part is second. So it is 180 degrees out of phase. And so those little dots indicate it being out of phase. If they were both on the top or both on the bottom, that would tell me that the output waveform was in phase with the input waveform. Alright, on the next video, we are going to talk a little bit more about calculations. We're going to go further into our ratio formula. And I didn't talk about it, but there are a number of mnemonics that you can use to help you remember that ratio formula. So one of them is nasty people eat pizza in sewers, with the idea that if you can remember all of the letters on the top, then you know that the bottom is the opposite. They also use nasty prostitutes earn pay in sheets. So there's just a couple for you. I'm sure they're going to cover them in class. But if you didn't, then hopefully that helps you out.